Hello SGD, Sacred Geometry Decoded, and this will be part 7 in the series, Unlocking the Giza Plateau, the Ancient Science of Astronomy, Geometry and Metrology of the Pyramids, where I've been looking at firstly how the Giza Plateau, or the three famous pyramids, actually connect to, for instance, the Khufu Valley Temple through the solstice and the equinox cycles, and also how that joins in a lovely geometric metrological pattern with Menkaure's pyramid as well, focused on the Khufu Valley Temple. Part 7, so now I want to do a focus on the Menkaure Pyramid, the smallest of the three most famous pyramids, but also how it links to the Great Pyramid, and in future also how Menkaure Pyramid links to this greater plan. I'll put the link to the playlist to the series in the description box, and especially part 4, where I look at these other pyramids just to the south, Neferefre, Pepi 1, Pepi 2, and these others which link so wonderfully to the metrology and the geometry of the Giza Plateau, as well as the layout of the larger complex. But so let's look at the geometry, the geometric connections of the pyramids. So we have the three most famous Giza pyramids, but also of the other grand pyramids. We have the Red, the Bent Pyramid, and the Meidum Pyramid, and how they join together, and how actually it's the Menkaure Pyramid which is such an important key to how these pyramids are proportioned to one another, as well as a larger plan in regards to the 0 point. So there's another image, the three pyramids, Menkaure, Khufu, and Khufu, or the Great Pyramid. I'll link these videos in the description because I'll be looking at the Fibonacci numbers and the Fibonacci Spiral, and how that's so important. Very simple geometry to get the layout, the basic proportions of the three Giza pyramids, and also how both the Fibonacci and Lucas numbers connect in a very lovely geometric mathematical way, pointing again to this ancient knowledge that has been preserved in these textbooks of stone. But Menkaure Pyramid, holds a key to the geometry which links the three Giza pyramids to the other grand pyramids of Egypt. So here's like some close-up views. There we see the northern side, with some very, very rare exceptions. All pyramids have their entrance to the northern side. This was a gash said to have been created by the son of Saladin. But also if we zoom in on these surviving casing stones, you can see where it's been almost finished and polished off, but then they never got quite around to finishing off the rest. And here we see these so-called nubs. Now it's important to remember that in whether it's Hieron of Alexandria or Vitruvius, these ancient Greco-Roman scientists, engineers who learnt through Egypt, such in places such as Heliopolis and the Library of Alexandria, they wrote very lovely scientific textbooks that describe not only the machines of lifting very, very heavy stones, but also that they understood the principles of it. And given that all this seemed to have come through Babylon or Egypt, this Greco-Roman technology at least has a significant portion of its genesis based in Egypt. But these were some of the techniques they used to lift stones, and the important one here to feature is the handling boss, or the lifting boss, which is still used today. We even still use grips or clamps today, and this Lewis as well. And here's a surviving ancient Roman Lewis. It's a very simple device, yet very, very strong, and an awesome way of lifting. So you just need to carve a small notch in there, and it wedges in, and it's awesome lifting technology, very simple, still used today, and again described in the ancient texts on lifting. And so you still see these features on, well, all across the ancient world, lifting or handling bosses. But the important, so Strabo's geography, he describes his travels through the ancient world, and just to focus on Egypt, and he describes Menkaure's pyramid. Now these pyramids are near one another and on the same level, but farther on, at a greater height of the hill, is the third, which is smaller than the other two, though constructed at much greater expense. For the foundations almost to the middle is made of black stone, the stone from which mortars are made, being brought from a great distance, for it is brought from the mountains of Ethiopia, and because of its being hard and difficult to work into shape, it rendered the undertaking very expensive. Now it's important to note when Romans spoke about Ethiopia, that was more of a generic term from Africa. It doesn't necessarily mean the nation we now think of as Ethiopia. Ethiopia or Ethiopians was a Roman, especially Roman term just for Africa in general. And they considered Africa everything on the west bank of the Nile and south of the cataracts of Egypt. And there we see the Menkaure Pyramid and the Gash, said to have been done by the son of Saladin, but okay, I won't go into that. Their skill at the time, apparently some legends say it took them 8 months to do that, but their skill at the time, that's with feather and wedge, very simple stonemason techniques, you could do much more damage in 8 months than that. But let's move on. Another very important thing about the Menkaure Pyramid is that it seems to be the origin of the Cinderella story. And for instance, Strabo, he was told, visiting Egypt, he was told, they tell the fabulous story that when she was bathing, an eagle snatched one of her sandals from her maid and carried it to Memphis. While the king was administering justice in the open air, the eagle, when it arrived above his head, flung the sandal into his lap. The king stirred both by the beautiful shape of the sandal and by the strangeness of its occurrence, sent men in all directions into the country in quest of the woman who wore the sandal. When she was found in the city of Naucratis, she was brought up to Memphis, became the wife of the king, and when she died was honoured with the above-mentioned tomb. So the story that Strabo was told is that this was built for the wife of the king. And again, the lost sandal, the king sent out his men to find who owned the slipper of Cinderella. And this seems to be the Menkaure Pyramid in this story, which was told by Strabo, told to Strabo by the Egyptians. Seems to be the origin of the Cinderella story. So as so often is, these fairy tale stories have a very, very ancient origins, one of these archetypal stories. So I'll link that in the description. I did a video on that, but basically you get the bulk of the idea in there. So on to the geometry of the pyramids, and especially compass and straight edge geometry. These are the ancient rules of geometry where just with a straight edge, that's like an unmarked, like we use a ruler now, but an unmarked straight edge, and a compass, and constructing polygons and, well, doing your geometry. This type of geometry can also be used for mathematics. You can basically make a calculator where you can do plus, minus, divide and multiply with this same geometry, but also when it comes to architecture and just design in general. Also have a philosophy which goes around it, Plateau, Pythagoras, these mystery schools, all based on geometry. But so here we have the basic regular polygons in that each side is equal to one another. So an equilateral triangle, a perfect square, pentagon, hexagon, heptagon, seven-sided, octagon, nonagon, decagon, and undecagon, which is the 11-sided. You could go on, but these are just the important ones to think about because they have some key information in there. So Kepler, where there is matter, there is geometry. So these are the heart or the central angles of each of these squares. So that's basically if you find the center and then from each point. So how do you do that? The central angle of a polygon, it's basically 360 degrees divided by the number of sides. So 360 divided by 4 sides gives you 90 degrees. So if you draw it from the center to each corner, 90-degree angle. These are the angles, the central angle of each of these polygons that you see here. Geometry is knowledge that appears to be produced by human beings, yet whose meaning is totally independent of them. As far as you go back in time around this esoteric philosophy, again back to Pythagoras and Plato and, well, the evidence of Egypt much earlier, you cannot stress the importance of math and geometry enough. It is they're the foundation, the building blocks of science in general. So here where I have a tick are the polygons that you can draw perfectly just using the rules of compass and straight edge geometry. These can be done. Plateau, the knowledge of which geometry aims is the knowledge of the eternal. So now we have the 7-sided, the heptagon, the 9-sided nonagon, and the 11-sided Undecagon. You cannot draw them perfectly with compass and straight edge geometry. You can do close approximates, but to perfectly draw them you cannot, and this is an interesting feature. The 7, the 9, and the 11. Geometry is the art of correct reasoning from incorrectly drawn figures, and there you go. So these certain figures cannot be drawn perfectly. Compass and straight edge geometry, and let's begin with the Khufu or the Great Pyramid. Geometry enlightens the intellect and sets one's mind right. So the importance of geometry is that it's very rigid. The rules are universal. It's again one of these universal truths. It doesn't matter where you exist, anywhere in the universe, the laws will follow through. They're built into the very structure of the universe itself. And also it requires reasoning and logic to do it. You can't fudge geometry. And that's why it's considered one of the most important, or the basis fundamental sciences. So when it comes to the Great Pyramid, 440 Egyptian raw cubits at the base, 280 Egyptian raw cubits high, giving us a 7:11 ratio. You can't criticize geometry, it's never wrong. Well, that's why it's so important. So 7:11. Now, here we have these proportions built into the pyramid. I should have specified that it's a very close approximate of phi and pi. However, as I repeat often in other videos, if you include the slight variations on each side, it's essentially perfect on these. This is simplified 7:11. The average of the Great Pyramid base is 440 Egyptian raw cubits, but the shortest and the longest side is 20 centimeters separate. But the average perimeter divided by 4 gives you 440 Egyptian raw cubits. This is very profound knowledge, and it's generally said, oh, well, that's a coincidence. But when you look at the metrology and all these other features, I'll put the playlist to the other series, Understanding the Pyramids and the Ancient Sciences. It's beyond any reasonable doubt. Anyone, to be a reasonable person and look at the whole of it, and it's not, you can dismiss one or two, but when you build up even with the simplest probabilities, you keep building it up, and the probability of it being a coincidence in any other field would just be outright dismissed, that this would be coincidence. Yet because it's ancients, there's just a bias in there. But very important, 7:11. Inspiration is needed in geometry just as much as in poetry. So it can be seen to be very not exciting, because it's, the way we teach math and geometry in school now, it just destroys imagination and the interest in these things. But math, geometry, it's the building block for all of life, for all of chemistry, for the molecules themselves. Everything, the universe is built around geometry. It can be expressed geometrically. But the 7:11 proportion of a Great Pyramid, well, it's interesting to note that the first of those polygons which cannot be constructed with compass and straight edge, the first which for instance the heptagon or the 11-sided Undecagon or the 7-sided polygon, the central angle is not a whole number, it's not an integer. The 7 and 11 are the first two of these which do not divide into 7 divided by 360 divided by 7, 51.428 ... 360 divided by 11, 32.727272. This is interesting because these are the first two which don't divide into a whole integer, and they also are the 7 and the 11 of the Great Pyramid, which gives us this geometry, which gives us pi and the golden number, Euler's number, and all these other very, very important mathematical constants. I think it's also interesting in regards to pi being transcendental and phi being irrational, maybe in some time in the future to be proved to be a transcendental number, in that it it can't be expressed as a fraction. The 7 and the 11-sided polygon, you could express them as a fraction, but they're the first two that don't divide into 360 and lead to that geometry, at least the numerals, but there's more to it than that, of course. So geometry is the most complete science by David Hilbert, a famous mathematician. On his gravestone, we must know, we will know. And I think this is an important message to keep looking, and we will find things. We must keep looking. But so the 7, the 9 and the 11-sided polygon, they're the first three that cannot be constructed with compass and straight edge, 7 and the 11 on the Great Pyramid. Music is geometry in time, so the quadrivium, geometry, arithmetic, astronomy and music. In the past, these disciplines were connected, unlike now where they're unconnected, and maybe that's where the education system has lost us. Because if we learn, some people are good at music, some people are good at arithmetic, some people are into geometry and art, other people would be inspired by geometry, but by astronomy. Though by this separation, I believe we've lost something very important, because if you study music, you're forced to study arithmetic and geometry, and you learn that which you don't necessarily like if you study it via the quadrivium, that each of these disciplines is connected. And this is an important feature. But now let's look at the 9-sided, or the nonagon. It cannot be constructed with a compass and straight edge. However, its central angle does reduce to an integer, and it reduces to 40. Now 40 you cannot divide by 3 or 6 or 9. So if I go back, okay, so what you will notice about all these other constructible polygons, that's divisible by 3 and 6, divisible by 9, divisible by 3, 6 and 9. So like it's a Harshad number. 7 plus 2 is 9. 45, 4 plus 5 is 9. 36, 3 plus 6 is 9. That's one of the lovely things about the number 9 as well, but they're all divisible by 3, 6 or 9. But the nonagon is not. It is divisible by 40. And this is one of the reasons why it's impossible to construct with a regular polygon. But that 40-degree angle, now how does that join? Therefore the interior angle is 140 degrees, and therefore the exterior angle is 220 degrees. Now it's nice to note that the height of a pyramid, 280 Egyptian royal cubits, the base 440, divide each, so 140 times 2, 280, 220 times 2, 240. So the ratio between the interior and the exterior angle of the nonagon is 7 to 11. Again, the Great Pyramid angle. Which now brings us to, so where we have the Great Pyramid, because of the perspective it looks like it's smaller, but actually this is the smallest, and then we get larger, but Menkaure Pyramid. It is 125 Egyptian royal cubits high. On the north or the south side, it's 200 Egyptian royal cubits high. The west and the east side is 196, which is a lovely little feature. But so we're looking at the north or the south side, 200 Egyptian royal cubits, or 2 chords at the base, and 125 high. That gives us a 5 to 8 ratio. It's 5 high and 8 wide. It brings us back to Vitruvian Man, which the man is a measure of all things, and has in Vitruvius's 10 Book of Architecture, and then this image by Leonardo da Vinci, the circle radius is 5 and the edge length of the square is 8. We have a 5 to 8 ratio. These are 5 and 8 are Fibonacci numbers. So here we see a Fibonacci spiral, which you might recognize as the spiral in horns, in snails and shells, in hurricanes or cyclones. Also galaxies tend to create this spiral, and it's the spiral which literally describes the way that sunflowers grow. Also pine cones is built on the Fibonacci sequence. Fibonacci numbers 1, 1, and then 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, etc. This is a very simple but very profound sequence of numbers. I'll link this in the description. This Magic of Fibonacci numbers, Arthur Benjamin doing a TED talk. Again, he speaks to how these, if they were taught from an early age, this would inspire so much, encourage education. Now, for most people, math is like just a terrible thing to study at school, and that's because of the way it's taught. But that will be linked in the description. So back to the Menkaure Pyramid, 200 wide, 125 high, 5 to 8 ratio, and that Fibonacci spiral, 5 to 8. Now, in regards to the nonagon, so if you draw a diagonal across this rectangle, that would be 32.00538 degrees. Using the laws of geometry, such as in Euclid Book 1, Prop 9, we can bisect an angle. We can cut any angle in half, and we can do this with super accuracy based on the compass and straight edge rules. Therefore, I can divide that angle, then divide it again. 32 divided by 4, we get 8.00134, give or take a tiny fraction of a degree. And just by now I can add that, again following the acceptable rules of geometry, I add those two angles together and I'll get 40.0067 degrees, which is the central angle of a nonagon to very high precision. Therefore I can do a very high precision construction of the nonagon approximate, which has that 7 to 11 ratio coincidentally. Now I'm going to link video Geek37. He tested this for me on GeoGebra, and then from the concept of his Fibonacci spirals and squares, he's gone on, and just recently he's just been blasting out videos and doing just creating construction after construction with a very high approximate precision, very close to absolute accuracy, but these constructions are technically impossible, but he's doing super work, and he's just taken this Fibonacci square and rectangles and just built on it. I'll link his channel, and I'll especially link this video where he shows how this the Menkaure Pyramid at 5 to 8 ratio is a very, if not the most accurate, very close to the most accurate compass and straight edge construction using a nonagon, just using compass and straight edge. So those will be linked in the description. So the Menkaure Pyramid, the 5 to 8 ratio, as is in Man is the Measure of All Things, Vitruvius, and Leonardo da Vinci's illustration, Vitruvian Man, and the nonagon having the 7 to 11 angle ratio. So the Menkaure Pyramid, 8 to 5 ratio, Fibonacci sequence, Vitruvian Man, the connections with the nonagon and the proportions of the Great Pyramid itself. So now let's look at the geometric connections of the pyramid. And so the two Great Pyramids, the most famous, the Great Pyramid or Khufu, and Khafre Pyramid, because they're so large and impressive, they get the most attention. However, the Menkaure Pyramid, the smallest of those three, is key to linking the Plateau, the famous Giza Pyramids, to the other famous pyramids such as the Red Pyramid, the Bent Pyramid, and the Meidum Pyramid. 8 to 5 ratio, Fibonacci numbers. Vitruvian Man, that's the base to the height of a Menkaure Pyramid. So that 8 to 5 Fibonacci, well, that's one way to draw the the Menkaure Pyramid, and it's 200 wide. Now the Red and the Bent Pyramid are both 200 Egyptian raw cubits high. So the height of the Menkaure Pyramid is 5 to 8 the height of the Red and the Bent Pyramid. So we see the first of those connections. This ratio connects the height to the base, okay, so Menkaure Pyramid. Now the Great Pyramid has the 7 to 11 ratio. Now it's worth noting the Lucas numbers includes 7 and 11. And so we can draw a Lucas spiral to create the Great Pyramid. I'll link that video, I mentioned it earlier in this episode, where from the Vesica we can create Fibonacci spiral and a Lucas spiral, and then we also would describe the Khafre pyramid. All three pyramids, just from a very simple geometry, can be drawn very simply. And now the Meidum pyramid, 175 Egyptian raw cubits high, 275 Egyptian raw cubits wide. Although it's collapsed, there are surviving casing stones, so we know the base length, we know the angle, therefore we can reconstruct the height. And it just so happens, so the Great Pyramid is 7:11. The Meidum Pyramid is at a 7:11 ratio. But how much larger is the Great Pyramid to the Pyramid of Meidum? Well, 280 divided by 8 times 5 is 175. So the Great Pyramid is at a ratio, or let's put it this way, the Meidum Pyramid is at a ratio of 5 to 8 in comparison to the Great Pyramid, which is of course the ratio of Menkaure's Pyramid, which also gives you those nice geometric connections. So the Menkaure Pyramid, that simple Fibonacci sequence, 8 to 5 proportions, links the Khafre, the Khufu or the Great Pyramid, the Red Pyramid, the Bent Pyramid, and the Meidum Pyramid all together. This is a common feature, and earlier in the series I was speaking about the measures and the distances from the 0 point, the northwest corner of Khafre Valley Temple, how that joins. Well, I haven't covered it yet, but the Menkaure Pyramid also is a basic unit you could use to link these things together in a metrological, geometric way, and then also to join, for instance, the Bent Pyramid to the Giza complex. Now, Khafre's pyramid is 3 wide and 2 high. The Red Pyramid is 420 Egyptian raw cubits wide. Khufu, or the Great Pyramid, is 280 Egyptian raw cubits wide. Therefore, the base of the Red Pyramid to the height of the Great Pyramid is 3 to 2. Khafre Pyramid is 3 wide and 2 high. Episode 4, again, I'll link that in the description, because that also connects many other pyramids, and also the metrology of those other pyramids all joins in this together. This is either the most extraordinary set of coincidences in architecture of the ancient world, or it's a plan built on very simple yet profound, important geometry and metrology, of course. What you can measure the proportions and etc. So Menkaure Pyramid, the smallest of the 3 of the famous pyramids, yet it contains vital information on multiple levels to link other pyramids back to the main Giza pyramids. Also, the metrology in there links to several other aspects. The Cinderella story, the nonagon, and other features in there. Geometry is knowledge of the eternally existent. Pythagoras, Plato, geometry existed before creation. If you go through time and you look at the famous alchemists, hermeticists, scientists, across time, they all come back to geometry. And this is so important, because everything really is related to you cannot bypass it, whether it's chemistry, physics, math, architecture, engineering, just every science will come back to geometry in one form or another. Leonardo da Vinci, who studied the flower of life, you can look at his imagery in there as well, but learn how to see, realize that everything connects to everything else. Leonardo da Vinci, so along with the Easter egg of the Egyptian royal cubit being built into Vitruvian Man, we see other connections as well. Thank you for watching SGD Sacred Geometry Decoded. If you'd like to support this channel, I will put the link to a PayPal account that's been set up. So cheers, thanks for watching, have a good one. Small donations, everything's much appreciated. Like, share, comment as you will, that also help me out. Cheers and have a good one.